And welcome back to another episode of Tidal Flooding Talk, brought to you by the New Jersey Coastal Coalition in partnership with our broadcast media partner at Tri-X 57. We are in the middle of November here, and it is getting cold. We're in the middle of this cold snap that we have here across the area. I like a couple of snow flurries in my life. I still want a couple more 60s, though, before we wrap up the warm season for sure.
Yeah, Joe, I'm still adjusting to the time change. It always takes me a couple of weeks to get used to the early darkness. So still adjusting to that. I'm a winter aficionado. I love a good nor'easter. Not the problems that come with it, but hopefully some snow, and hopefully it'll be a good winter for that. And our guest today knows nor'easters well and everything weather, and really excited for the upcoming conversation.
Yeah, absolutely. We're super excited to have Dr. Michael Mann on. Such a pioneer and a legend in the climate space. He's the Presidential Distinguished Professor of Earth and Environmental Science and the Director of the Penn Center for Science, Sustainability, and the Media. We're going to talk about nor'easters in this climate-changing world. Dr. Mann, two questions. One, I'll say first, welcome to the show, and then one question here. How much of a snow fan are you?
Thanks. It's great to be with you guys. And I grew up in Western Massachusetts during the late 60s and 70s, back when we used to get those old-fashioned snowfalls that we talk about so much. And of course, they all seemed much, when you're 5 years old or 4 years old, the snow seems much higher because it's a larger fraction of your body height. But I grew up in the snow and spending a lot of time doing winter sports outside in the winter. And so it's sort of ingrained in me, and here in Philadelphia, we get a little bit of winter, not as much as we used to get. In fact, 2 winters ago, for the first time, as you may remember, we had 0 snowfall, the first time on record.
Yeah, I do remember that. I was further down the shore from where I am now in Monmouth County in Atlantic City, and we had the record lowest. And I think we all love snow. I think the three of us, we all love snow here. But if we're gonna break a record low, I guess that's kind of exciting. But I need the 30, 40 inches of snow in my life. You got to keep something interesting during the winter. So anyway,
I've got a story that we'll get to that involves about that much snow. One of the historic nor'easters not too many years ago.
Yeah, I'm looking forward to talking about it. So, this started where actually Dr. Bill Thomas, he's our number 2 at the New Jersey Coastal Coalition, sent me this article from CNN saying the next, quote, storm of the century could be even stronger, new study shows. And this was research, done by yourself. Just a quote from the article, there is a general consensus there will be fewer nor'easters in a warming world. But what has remained unclear is what will happen to the intensity of these storms, which have tended to be understudied. So what was the inspiration for you to get into this space and think about nor'easters in this climate changing world?
Yeah, I've sort of always been interested in these storms, grew up, with these storms. They're just fascinating storms, right? Because they're not like your typical mid-latitude cyclone. Part of the energy that that these storms sort of feed on is the evaporation of water from the ocean surface, the heat that's given off during that evaporation process, and it shares that in common with a tropical storm or hurricane. And so it's this interesting sort of hybrid. It's somewhere between a typical mid-latitude cyclone and a tropical cyclone. Some nor'easters actually do develop something that almost looks like an eye. And so I've always been interested in these storms, but there was a specific episode that actually in some ways spurred this particular study. And it relates to where I am now at the University of Pennsylvania. This was back in February 2010. You may remember I think this is what we called Snowmageddon.
Snowmageddon, oh yeah.
Snowmageddon.
Yeah, we love that.
So I was at Penn State University and scheduled to give a talk here at Penn in the physics department, in fact, on February, I forget the exact date, 9 or 10, and arrived at drove, from State College to Philadelphia, was staying at a hotel just off Rittenhouse Square, and then the snow began to fall, and we experienced this historic nor'easter known as Snowmageddon that in the end, I think, deposited about 3 feet of snow in the area. You couldn't drive in Philadelphia. The interstate was shut down, so there's no way I could drive home. I was stuck in my hotel for 3 days because Penn never reopened. We delayed it a day, then we delayed the talk another day, and then finally we just gave up. And so it was because of Snowmageddon that I wasn't able to give this talk at the University of Pennsylvania. 10 years later, a little more than 10 years later, I would actually move to the University of Pennsylvania and actually took a graduate student who was interested in these sorts of storms, and we decided it would be really fascinating to see, if there's something going on. Are we seeing more, snowpocalypse, Snowmageddon, the perfect storm, these extratropical storms that have names, right? Is there something going on? Is there a change in the characteristics of these storms? And to address that, we had to dig into what are known as reanalysis data, because we don't have continuous measurements of all of the variables that we would like to have to analyze storm characteristics going back 75 years. And so we turn to what are known as reanalysis data, where we take the observations we have, we feed them into a numerical weather forecasting model, and the model figures out what the data is, what the measurements ought to have been, what we think they were, in the places where we don't actually have direct measurements. And that gives you sort of a continuous, complete data set that you can analyze for the characteristics of storms, for the maximum sustained winds, or the snowfall totals. And so we use these reanalysis data to actually we used a tracking algorithm to find every single nor'easter and follow where it went and how intense it got and how much precipitation it produced, and built up this atlas of 75 years of all of the nor'easters that entered into a large rectangular box along the east coast that we sort of think of as the area that experiences these storms, and decided to go in and see what we could find.
Fascinating. I kind of share your fascination. I grew up in Eastern Massachusetts. So blizzard of 78, I was 3, but I always say that sparked my my love of weather. And the year you mentioned, Joe, you know this too well, 3 blizzards in South Jersey at the shore, December 2009, February 2010, December 2010, the likes of which we haven't seen since. So I guess, Dr. Mann, my question to you.
I was just going to say, Dan, I wanted to mention that we were the Amherst Hurricanes.
Yeah. Oh, really? Okay.
I grew up in Western Massachusetts, Amherst High School,
yep.
And we were named after the 1938 hurricane that came through.
Oh, wow. Yeah. Cool.
That's awesome. Well, what did your research show as far as where we've been with nor'easters, and I guess more importantly for the nor'easter and snow lover and all of us, what the future may hold due to climate change?
Yeah, so one of the things that's interesting, like I said, about these storms, unlike a typical mid-latitude cyclone, a typical storm that we experience, in the winter here in the United States, these storms, part of the energy is derived from latent heating, from the latent heat release when the oceans evaporate moisture into the atmosphere. And so that makes them sort of special, and that gives them something in common in terms of their characteristics with tropical cyclones, with hurricanes. And one of the things we understand fairly well, there's a fairly well-developed theoretical foundation developed by Kerry Emanuel of MIT for understanding how warming of the ocean is likely to impact the intensification of hurricanes. And so there's a pretty solid theoretical foundation that tells us that the strongest hurricanes ought to get stronger. Will there be more tropical storms? We don't know, because there are a whole bunch of factors that come into it. But those storms that do form are capable of becoming stronger as we warm up the oceans. And I say that just a week after we witnessed what may, during postseason analysis, go down as the strongest Atlantic hurricane on record in Melissa. We'll have to see what the National Hurricane Center sort of decides after they review the data. And so we are seeing this increase in the intensity of hurricanes. And since nor'easters share that characteristic, the energy released from a relatively warm ocean surface, part of what drives and intensifies these storms, there is some, there is a literature now. There are a number of studies that suggest that we ought to see more, stronger nor'easters. The strongest nor'easters ought to be even stronger in the future because of warming. But the question was, can we actually see that in the data that we have historically? And that requires that you turn into these reanalysis data, and they're caveats because they're not simple data. They're a combination of models and observations. And so you have to think about, all of the possible sources of uncertainty in those data. But what we did find was that there was a pretty clear increase. It amounts to a roughly 8% increase in the maximum wind speeds of these nor'easters over time. Now, there have been some really strong and impactful nor'easters. We all remember the 1962 Ash Wednesday storm, which by some measures was the most damaging nor'easter on record. But what we did find is there are more of these very intense storms where those central pressures, we used a criterion that the central pressure had to be below 960 millibars. So we were interested in the strongest nor'easters, and typically there are a handful of nor'easters each season that reach that level, that strength. Such a low central pressure, which is one measure of the intensity, the other being the maximum sustained winds. And so what we found was that there was this trend over time towards more of these very strong storms, and it amounted to an increase of about 8% increase in maximum wind speeds over the 75-year period of analysis. And so you look at that, you say 8% sounds sort of like it's not too impressive, right? But you have to remember that, for example, the destructive potential of a storm, of those winds, actually goes as the third power of the wind speed. So an 8% increase in wind speed can actually translate to like I think it was maybe 7%. Now I'm trying to remember. It was a 6% increase in wind speed, which doesn't sound that impressive, even less impressive than 8. It was 6% over the period that we studied. But the damage that can be done by those winds goes as the third power, so that 6% turns into about a 20% increase in the destructive potential of those storms. And similarly, the storm surge that you can generate increases fairly dramatically as you increase those maximum wind speeds, and especially as you get to larger and larger storms. Large storm with high winds, like the Ash Wednesday storm, can lead to those monumental storm surges that we've seen along the Jersey coast with some of these storms.
Yeah, and we saw not the 62 storm, but something similar with the nor'easter in October. We had a long duration of tidal flooding across the area. We'll talk more about that in a little bit. Let's take one break here, and we'll be back on tidal flooding. Thanks to the New Jersey Coastal Coalition, your flood insurance bills are lower and your streets safer from the reality of flooding. Since beginning in 2013, we build more resilient shoreline communities. Our member towns develop and share in best practices that anticipate future concerns and create flooding solutions. From our town-specific free web app for flooding information to our weekly Tidal Flooding Talk show, we focus on flooding 24/7. Visit www.njcoastalcoalition.com for more.
Well, welcome back to this week's Tidal Flooding Talk with meteorologist Joe Martucci. I'm Dan Skeldon. Our guest, we're honored to continue our conversation with Dr. Michael Mann, talking nor'easters, climate change, tidal flooding, and how everything is kind of intertwined. And looking forward, Dr. Mann, fewer but fiercer nor'easters. We are the New Jersey Coastal Coalition, so we talk storms. We got to focus on tidal flooding. What is the effect? The storms are fiercer, the climate is warming, the climate is changing. What can coastal residents expect as far as maybe changes in the increase or the severity and the frequency of tidal flooding and its impacts along coast?
Yeah, it's something that we see here in Philadelphia, quite a bit of flooding, the estuarine outlets of the Delaware. And this is, something that we're going to have to deal with increasingly as we face more of these very strong storms. Often the problem is what we call compound flooding, where you get the storm surge from the ocean, but you get a large amount of precipitation. Now, if it's rainfall, then it's going to fall as water. If it's snowfall, then you're getting snow, you're getting a coastal surge. It can get really messy. And so, and we have seen some devastating storms like the Ash Wednesday storm of 1962. And so what we're looking at is potentially more of those sorts of storms, those very impactful storms with high winds that can do substantial wind damage, very large amounts of precipitation, paralyzing snowfalls, and then that storm surge, which for those along the coast or estuarine regions, like here in Philadelphia. That's something that we have to think about. There's so much focus on sort of the coastal threat of hurricanes. And by some measure, those are the most impressive storms on the planet, so it's understandable. But sort of nor'easters are like the ignored stepchild. They don't get nearly as much respect, but they can be every bit as impactful. Again, you look at the Ash Wednesday storm, but there are other examples. Even early this season, we saw one of those fairly substantial nor'easters that had an impact of us here.
Just a quick follow-up. How do you think we kind of fix that disparity? Hurricanes have a fixed season. You have a National Hurricane Center. You don't have a National Nor'easter Center. Hurricanes get names, unless you're the Weather Channel. Nor'easters don't. But how do we kind of fix this and kind of warn and educate, especially residents that are standing to be impacted by this, that they can be just as bad, and in the case of the 62 storm, worse than some of the hurricanes that run up the East Coast?
Yeah, and how do we do that without dividing the meteorological community? That naming extratropical storms became a very contentious matter. Amazingly, even more contentious than climate change.
I would agree.
So, I think, one of the things that we're trying to create a research community, and it turns out we have some of the best researchers when it comes to studying nor'easters. We've got folks at Rutgers. Tony Broccoli and his group are doing really important work in that area.
All my friends.
No, they're doing wonderful work there. We've got folks at Rowan University, not too far from here. Sure. Researchers there who are also sort of studying these sorts of coastal storms. There's a paleo component. I have a student working with folks at Drexel trying to reconstruct the history of nor'easters using coastal sediment cores. So here in the area, we're sort of developing a network of researchers who are focused on these sorts of storms. We are increasingly, there are sessions, for example, at the AGU, the big American Geophysical Union, American Meteorological Society as well, the annual conferences focused on these storms. So I think if we can get our young researchers interested in these storms, so many of them want to study hurricanes, and it's understandable. Some of us are trying to redirect them. In fact, one of the jokes that I tell is one of my graduate students was actually an undergraduate doing research on hurricanes, and then she applied to work with me, and we convinced her to go extratropical, to go from hurricanes to mid-latitude cyclones. And it turns out, you can draw upon the training, because, it's the same equations, it's, the same variables that you're working with. And so I think to the extent that we can get more researchers involved in studying these storms, create more excitement and buzz around them, and make people understand how impactful they are. For those of us who live along the mid-Atlantic, these storms are every bit as impactful as the relatively few hurricanes that make landfall here. And so I think that, it's a cultural change, but I also think that unfortunately Mother Nature may have something to say about this as well. If it is indeed true that we continue to see this trend towards more powerful nor'easters, they're only going to become a more prominent part of the discussion.
Well, like we say at the New Jersey Coastal Coalition, whether or not you decide coastal flooding is an issue for you, Mother Nature has already decided that, for you, right? So, that's what we preach at the NJCC. So we're going to take one more break, and then we'll come back on the other side here with Dr. Michael Mann.
Champion with us in Atlantic City.
All right, and we are back for our final segment of Tidal Flooding Talk. The New Jersey Coastal Coalition wants to remind all of our coastal dwellers that tidal flooding, or even nuisance flooding, isn't a minor splash. It's seawater creeping into streets, basements, and backyards during high tides with no storm required. With sea levels rising, these events are hitting more often at the Jersey Shore and beyond. But here's the good news. You can fight back with smart prep and resilience hacks, like knowing your risk zone. And you can do that on NOAA's Sea Level Rise Viewer. All right. So this question it's not directly related to the story here, but I think it's relevant for people to know. You said equations, right? And I don't know if people really understand the depth of meteorology. I'm not asking you to recite, the Clausius-Clapeyron equation, although you probably could. But just give us an idea of the type of math that goes into meteorology for our general listening audience.
Yeah, thanks for the question. I was a physics refugee, started out graduate school studying physics, applied math and physics undergraduate, graduate school in physics, and then realized that there was this burgeoning field of, atmospheric science, but climate science in particular. This is back in the early 90s, where if you knew your physics and you knew your math, you could work on some really interesting big problems. In physics, there were a lot of people working on the really interesting problems. But if you went into atmospheric science, oceanography, and climate science, there was sort of wide open areas of active inquiry into all sorts of interesting questions. And climate modeling was really just sort of getting off the ground. We were just starting to see the sort of the more sophisticated climate models that scientists run today. And so I took all that math and physics with me when I switched into the Department of Geology and Geophysics to instead do my PhD there with Barry Saltzman, who is a dynamical meteorologist by training, who got interested in the ice ages. As he went on in his career, he went from weather to ice ages. The time scales got longer and longer as he got older. And decided to work with him modeling Earth's climate system. And I can tell you, in some of the work that we do, the mathematics that's required to solve some of the wave equations that emerge when you study the behavior of the atmosphere, you use the mathematical methods that were developed in the early 1900s to solve problems in quantum mechanics. So we're talking about some pretty heavy, pretty detailed math, some pretty sophisticated math that's actually necessary if you want to understand, for example, how the jet stream is changing during the summer as a function of the warming of the planet. And so some other research of mine involves understanding the phenomenon of resonance, where the jet stream sort of gets stuck into a very stable configuration, a very wavy stable configuration with highs and lows that stay in place for days on end, and you get those very persistent weather extremes. Well, you actually need to use the math that was developed to solve problems in quantum mechanics to solve that problem. So it's some pretty serious math.
Yeah, Dr. Mann, I don't know if Joe has this too, but I have nightmares still over the math I had in college.
Yeah.
We were in the engineering program in my meteorology school, and It was intense, but as you said, absolutely necessary for the science.
Well,
So,
the wonderful thing about this field is that people from all different, with all different types of skills can contribute in important ways. So some people come in with the math and the physics. Some people come in with the geosciences, and they add something new. And it's this sort of mixing bowl where you bring all of these scientists who come from different areas, and each has something to bring with them. So yeah, the math and
very good
physics can
point.
be important, but all the other stuff is important too.
Absolutely, couldn't agree more. Now, I feel like you're the type of guest we could easily fill an hour or two with. 30 minutes just flies by. But before we wrap up, I do want you to have an opportunity to talk about your new book, which is
Oh
over
yeah.
your right shoulder there,
Yeah.
Science Under Siege, and tell our listeners and viewers a little bit about that.
Yeah, thanks. So this came about because a colleague of mine, Peter Hotez, he's a vaccine scientist, and back during the early days of the pandemic, he was finding himself criticized by people who didn't believe the science of vaccines and were attacking him, and it was similar to what climate scientists like myself had experienced, but those who don't accept the science of climate change. And we realized that there was a common thread here, and we actually became friends. We realized that there was a book to write about our common experiences, whether it's climate or the pandemic, vaccines, this sort of very fraught environment we now find ourselves in when it comes to science, the implications of which sometimes threatens, people with certain views, certain ideologies, certain politics, and the problem is that these are the great challenges we face: the climate crisis, ever more deadly pandemics, in part because of how climate change is impacting the spread of these zoonotic diseases, and so what's so frustrating is some of the great challenges that we face as a civilization require us to understand the science and to use science and technology to address these problems. But there's so much misinformation today that it makes it very difficult for us to tackle these challenges. And that's what the book is about. And there's also a message there about how do we change this? How do we change, what can we do? Well, one thing is you can vote for, policymakers who you feel are follow the science and want to help us solve these problems, because none of us as individuals can solve these problems alone. We need to work together to do that. We need policies that will take us in that direction. So that's sort of the point of the book. We started writing it about 2 years ago, so we actually had no idea that it would come out during this very unique environment we now find ourselves in, where there really is, science is under siege in a way we couldn't have imagined. Oops,
Dan, you're on mute.
Hear you.
Sorry about that. Where can people get the book? Is it available now? And if so, how do people, if they're interested, get a copy?
Yeah, thanks. You can find it on all the booksellers, Amazon, Barnes & Noble. You can go to Public Affairs, which is the publisher, or bookshop.org is a great way to find your local bookseller, because I sort of like, I'm old-fashioned. I like to help out our local booksellers. And you can find it in most bookstores. If you go into Barnes & Noble, there's a good chance you can find it there too.
Great.
Yep. Great. All right. Well, Dr. Mann, thanks so much. We really appreciate you coming on. We're not done with you just yet, though.
No worries.
We're going to do the one thing we can't stop talking about, tidal flooding or otherwise. Dan, I'm putting you on the hot seat here. I'm going to have you go first.
Mine's easy. It's related to how we opened the show, and it's about the upcoming winter. People always look for winter forecasts, which I'm not a big fan of, the big seasonal forecast, but I'm really liking the look of December for a cold and snowy start to winter in the Northeast. I'm hoping for a nor'easter or two, not a 62 storm, but something that can give us some snow around the holidays.
Well, so are we. I have to confess, we've got a horse in this race, because one of my students actually goes out to when these nor'easters strike. She actually goes down to the shore and makes cores and studies the sediments and how
wow.
so that we can interpret the past. And so we love these nor'easters because we can actually go out and make some really important measurements.
Awesome.
I'm with you too. I'm a bit of a weather weenie, and I think we're due for that. We're due for an old-fashioned winter. We're in a strange place. If you look at sort of the underlying large-scale climate drivers, we're sort of going into a La Nina. We were sort of in an El Nino. We're sort of going into a La Nina. You can often get colder than average winters in the northern half of the U.S. The winter sort of that corresponds to the emergence of a La Nina event. So if that pattern holds, that would sort of support your prediction here.
Fingers crossed.
Yeah.
Fingers crossed. Fingers crossed. I'm gonna go with the one thing I can't stop talking about. I'll keep it in the weather world for this one, and that's temperatures in the 50s. Dr. Mann, I just don't like temperatures in the 50s. Like it's like purgatory. It's weather purgatory. It's not winter. It's not t-shirt weather.
Oh, so you're talking Fahrenheit?
Yes. Yeah. Oh, yeah. I mean, 50 Celsius. I don't know if I like that one either.
Yeah, that's not good.
But yeah, temperatures in the 50s Fahrenheit. Not a fan of. I don't think I like any 50s. 50 Celsius, 50s Fahrenheit, or 50 Kelvin. Imagine if it was 50 Kelvin out. We'd be icicles out there. That's very close to absolute zero for people who don't know Kelvin. But
no,
yeah,
I hear you. You want it cold or warm?
That's right.
No, can you go to the beach or can you go skiing?
That's absolutely correct. So we'll leave it off with you. What's the one thing? Tidal flooding or otherwise?
Oh, so or otherwise.
Or otherwise.
Yeah, I'm thinking about just sort of. I'm still thinking about the science under siege. I'm thinking about it. Maybe we're starting to. Maybe there's a growing awareness that we're not in a good place, and that people are actually going to get behind supporting government scientists and the work that they're doing. I think that's so important. Our friends at places like NOAA that do such important work. It's a difficult time for them right now, and maybe we're seeing a turn in the tide as far as that's concerned.
No pun intended for Tidal Flooding Talk.
Pun completely intended.
No pun intended. All right, great. Well, Dr. Mann, thank you so much. We appreciate it. Where can we follow you for everybody?
Okay. So I'm on most of the social media. So I'm on Blue Sky, Twitter, or now X, Facebook, Instagram, LinkedIn, and you can just find me at michaelmann.net at my website. It's got links to interviews and in the books and other things that we do. So yeah, please do.
Great.
All right. Well, we're going to wrap it up for this week's edition of Tidal Flooding Talk. We thank Dr. Mann again. I'm Joe Martucci. Night, hopefully with Palma Shiles, as well as we talk about tidal flooding and everything across the coastal areas.